Okay.
Miroslav es el autor de SQL Map, entre otras herramientas como MailTrail, y tiene una gran, digamos, trayectoria dentro de todo lo que es los temas de ciberseguridad. Él es croata, nacionalidad croata, y bueno, nos va a contar hoy día esta tremenda presentación que nos trae para compartir con los amigos de Bsides. Sí, Franco.
So this is something I like to start my day with. So I open one of my textual editors and just write stuff that I would like to do that day. So nothing, I would say, pretentious, so nothing too complicated, really some small stuff that I would like to finish for that day. And here I put everyday stuff that are not so technical, private stuff and the technical. So for example, for the SQL map, go through all issues, make one commit. For the mal trail, merge all pull requests or do some collection of the IOCs. Also, I do stuff here, or I would say write stuff for the everyday work. So as I'm also the, I would say, eager CTFer, so I like to place those, capture the flags. This is also one of my, I would say, ways how to capture those flags. So each day I write stuff that I would like to capture for that day. So for the SQL map, short project introduction. So it's, I would say, all-in-one tool for detection and exploitation of the SQL injection flows. It's written in Python 2 and for last year and a half, Python 3 is also being introduced. I would say the integration with the Python 3 is over. Also, one important thing is that it's the project itself is 14 years old, and in 14 years, if you do, as said, one tiny step at a time, or I would say, also you can say baby step at a time, after 14 years you have a, I would say, full-grown child. And there are two authors, who I would say core developers, Bernardo Damel and myself. So two people are responsible for the SQL map. One, I would say, nice note is that we are really, I would say, accurate in terms of finding flaws, and we are really trying our best to have as smaller number of false positives as possible. So if you catch something with the SQL map, most probably you will have the SQL injection and something that is actually being usable. So then some numbers. So currently we support 32 different database management systems: MySQL, Microsoft SQL Server, Postgres, Oracle, and so on. So I would say quite a hefty bunch. 6 supported SQL injection techniques. You most probably heard of stuff like Boolean-based blind, arrow-based blind, union-based blind, stacked, in-band, and stuff like that. This is one of, I would say, astounding numbers. Currently, we have more than 4,000 user-reported issues which are closed in last 8 years. And that's, I would say, quite amazing number. So SQL map is constantly being developed and I would say supported by us. So there are lots and lots of I would say user interaction going on, and lots of, I would say, Q&As and stuff as that. Lots of commits, so more than 9,000 commits, more than 72,000 lines of code, and down there you can see some statistics for our official main page and the GitHub page. So we have roughly around 10,000 unique web visitors on those pages. So that's, I would say, quite large number. So it's something that is really, I would say, boosting our morale. So users like our tools and like our job, so they tend to come back to us and to see what's going on. Also, there are new users, and there is one funny thing that I really thought that that SQL injection will die like 5-6 years ago, but it seems that it won't die so easily. So that's the, I would say, one of good things in the SQL map itself. So it is tool that in 14 years of development, we really ended as the, I would say, best SQL injection tool in the world. It's not so, I would say, hard to be the best if you have 14 years of development on something. I would say if you do 14 years of tiny steps into a single project. We have a wide industry recognition, so in lots of those surveys and I would say in lots of those distributions, we are considered as one of top 10 security tools. We are also introduced into official non-offensive distributions. So you can see here a number of 54 distributions that officially have the SQL map as part of, I would say, all other benign tools. So I would say SQL map has become an industry standard for the SQL injection stuff, even for the offensive and for the defensive side. Here you can see the numbers of the unique cloners in one, I would say those are 2 weeks of time. So we have more than 10,000 unique cloners. So those numbers are quite, I would say, catchy, because here we know that we are responsible for something that is really, really, I would say, important for the Y community. So stopping development of this would be, I would say, detrimental for the whole I would say, InfoSec community. So it's something that we like to do because you can see that it's quite popular. Now, how does it look to do those tiny steps, or I would like to say baby steps in the development? Here you can see that there is a continuous commitment into the repository itself. So there is no stop. Here and there we have some, I would say, flashes of some brilliant ideas, but at the end it's really important to not stop the development. So I would say in the last couple of years, SQL map has become really stable as a tool, but that there is a never-ending development of the stuff that you as the end user won't see, or I would say won't notice once running the tool, but it's something that really helps the users to cope with the SQL injection vulnerabilities, if there is one to be used. So this is also one nice, I would say, graph of the commits. This for last maybe 2 months. So there is continuous development, I would say, lots of fixes, implementations, lots of patching, lots of user support. So as said, the end users won't notice this, but now I'm showing you that there are always some baby steps going on in the development of project like this. Also, here you can see those, I would say, we could say major milestones. So each year we try to put the major milestone pointing that the second number is showing the number of that major milestone. So current major milestone was the 1.5. So that was the milestone put on the January 1st of, I would say 1.4 was for this year. So it was made on the January 1st of this year, and 1.5 will be the one in the 2021. So each of those major milestones have a certain number of closed issues. So there are lots of as said, user suggested enhancements or the bug fixes going on. Also, along those major milestones, we have the minor milestones. So those minor milestones are all made on the start of the month. So each start of the month, we have those minor releases. So current minor release, the 1.4.11, that's ending marker is for the November, or I'd say the cardinal number of the month itself. Also, in terms of introducing new stuff into the SQL Map, we have, I would say, periodic announcements on the Twitter, whether we did some major, I would say, cool and new stuff. So as you can see there, lately we did some introduction of the support for, I would say, not so popular database management systems, but something that's here and there you will come if you're doing stuff like bug bounty or doing some obscure system penetration tests. Now I would like to show you some tools that are really helping in those gradual implementations. So I would say those baby steps. So to do those baby steps, we have, I would say, strong backend support in terms of the functionality to really test that everything is fine once introduced into the repository. As you've seen, there are lots of users that use the SQL Map, so it's really, I would say, problematic if we introduce something into the repository and which breaks the installation for tens of thousands of users. So here I'll show you some, I would say, backend testing or backend tools that are really doing an awesome job on preventing those kind of, I would say, unnecessary problems. So one of those tools, or I would say mechanisms, is the continuous integration being done with the Travis CI. So there we have the development environment, I would say testing environment on all, I would say, those popular Python versions, so Python 2 and Python 3 and the Python 3.9, which has lots of changes compared to the previous Python 3 versions. So once the commit is being pushed to the repository, immediately there is a spawned testing environment on the Travis CI, which is doing the background checks to see whether something is broken or not. And in case of being broken, we are immediately being backed via the email. How does it look like inside the testing environment? So there is something called smoke testing and the vulnerability server testing going on. So for that build tests to pass, those two, I would say, battery tests have to pass. So to show you what's going on in those tests, so smoke testing, there are lots of those so-called doc tests inside the source code. So for each, or I would say for majority of functions, there are some small tests for each function, which you put the input value and you put the expected value down below. So if those two values are not, I would say, or if the expected value is not the same inside that testing environment, the whole battery of tests just fails. Here you can see some numbers. So once those smoke tests are being run, this is the example for being run on my local, I would say, on my laptop environment. So those numbers are like that 318 Python files, and in each file there's, I would say, approximately like 10-20 doc tests. So we can say that there are a couple of thousands of those small documentation tests being implemented, and each of those tests have to be, I would say, passed once even a slight commit is being pushed to the repository. Along the smoke testing, we have the vuln testing, or I would say vulnerability server testing. So vulnerability server testing is, we are actually making a deliberately vulnerable server locally, and we are running SQL Map against that locally spawned vulnerable server. So inside of that server, we have some tables, we have some functionalities, we have some vulnerabilities, and you can see here there are lots of those vulnerabilities tests. So against the vulnerability server, lots of SQL Map runs are being done with different switches, where those, you can see the yellow underlined switches are being used, and you can see the red underlined expected texture content that has to be inside the output itself for that single test to pass. There are over, I would say, I believe there are 50-60 different vulnerability tests. So this is really something that is, I would say, strong, because, as said, each commit triggers those battery of tests. So you can imagine that for SQL Map to I would say, to pass all those tests, it really has to be, I would say, in great shape. So nothing, I would say, there's a really minor chances for error to go through all those tests. How does it look like when being run on my local laptop environment? So all those tests against the locally spawned vulnerable server, all those tests have to be passed for that vuln test to pass. Now, other tool that I wanted to show you, which also is really helpful in doing those tiny steps. So to do the continuous integration, continuous development, you have to have the solid, I would say, battery of vulnerable servers. So we created one virtual machine locally with lots and lots and lots and lots of database management systems. And for each of those database management systems, we created a vulnerable page and filled the database with some data. And this is something that is really useful, because if you don't have something like this and you are doing the tool for the SQL injection, you won't be able to, I would say, neither to implement new stuff, or you won't be able to properly triage the issues of the users. So if user, for example, says, okay, I have problems with the Percona database management system, and if you don't have all the available server with that database management system with the vulnerable page, you won't be able to do anything. So testbed is something that is really helping us in continuous development, because we don't have problems now with the, I would say, with the source of the vulnerable pages. So we don't have to do any kind of illegal stuff, nor finding any third-party vulnerable pages. We have everything locally. So we are, I would say, good guys doing development on our local machines, so we don't break law. We just do tests locally. How does it look like when everything is spawned? So each of those database management systems have a separate Docker. So each Docker is representing one database management system along with the vulnerable page. So if you turn on all those DBMSs in the same time, it is possible to do it. And you can see here, those are not all, but I would say majority. You have to have lots of RAM, lots of memory. It will be kind of sluggish, but when we do tests, we just spawn a single Docker with the database management system that we need. Later on, we just shut it down, and next time we start what we need. How does it look like from the when you're looking from the browser itself? So you just browse to the testbed, and you're being immediately shown with all the database management systems that are being that were implemented into the testbed. You just click on one of those, and you will immediately get the database, which is, or I would say, the vulnerable page, which is usable by the SQL map. So in this case, you have the MIMR SQL, and you have that famous single quotes. You have the syntax error. So most probably there is some kind of SQL injection possible. And if you just, well, I would say, if we just take this URL and put it into our SQL map, we are immediately or I would say, are able to do stuff on the MIMR SQL. The third tool I wanted to show, which is really helpful, is something called Sql Map Reporter. So if you are a regular user of the Sql Map, most probably you have found this kind of, I would say, listing inside the Sql Map run. So here and there, if there is some major issue inside the SQL map, you are being presented with this kind of anonymized stack trace, which you can send us as an anonymous user to the official GitHub repository. And this is everything we need to have for us to reproduce the issue. So this is something that is voluntary, being sent by the users. And this is really, really, really helpful. I would say this most helpful thing for finding bugs inside the SQL map. So if users are really running with some obscure switches against some obscure database management systems, so they have, I would say, wide coverage of the lots of functionalities of the SQL map. If there is some problem, they'll be presented with this kind of a handle exception message, which is anonymized. So there are no, I would say, things that can compromise the user. They are being told whether they want to share the data with us or not. This is something that is, I would say, helping a lot in continuous development, I would say, or continuous stabilization with SQL map. How does it look like inside the GitHub repository? So this kind of a handler message is being pushed to the sql map repository. So we have the identical copy of that handler message with the entity called sql map reporter, which says, okay, some user had problems, you should take care of it. Also, there is one nice thingy called the unique ID of the handler message. So this is the digest of some control points inside the handler message. So this is something that we use, or I would say that is helpful to prevent the spamming of the new issues. So if you're running some older version of the sql map and that same issue is already fixed inside the sql map, the sql map reporter will check whether that issue is was already reported or closed inside the repository, and if it is, the user will be notice that he is running some older version and he has to update to the latest version to have it fixed. You can see here the heat map of the contributions of that, I would say, meta user called sql map reporter. You can see that there is a continuous user contributions, or I would say automated user contributions during the year. Funny thing is that, as said, there is a slight chance, I would say really small chance for something to break the repository itself after all those rigorous tests, but at the end there is a possibility. Funny thing is that latest issue that caused some problems in the users and that wasn't handled by those smoke tests and the vuln tests was immediately being like in 5 or 10 minutes after it was being pushed to the repository, it was immediately being reported by the sql map reporter by some, I would say, eager user that pulled the latest version and run the sql map against some vulnerable target. How does it look like inside the Gmail? So once being pushed here to the repository, we are immediately being noticed by the email. Okay, there is some handler exception being triggered by the sql map reporter. We get this kind of critical label. That critical label is something, as you can imagine, something critical. So I really like to deal with those kind of issues immediately, because as you've seen, there are lots of users using sql map. So once I see this kind of a handler message, I immediately try to solve it. And I have to show you that latest tiny step that is being done inside, or I would say introduced into the sql map. So something called Json Aggregation. So that's same functionality, something that you as the end user most probably won't notice it. You will just run sql map and do the table dumps. But most probably you will notice that in some cases you will have instant access to the database content. And what is it about? So it is about putting the whole query results into a single JSON array. So thing is that there is a nice feature inside the latest database management system versions called Json Aggregation. You just put the one select statement inside some function which is being used for the Json aggregation, and it what it does, it creates a JSON serialized object out of those results. And cool thing is that inside the SQL injection, or I would say inside the sql map, you can have a one query per one table dump. So you just put everything inside the one JSON array and you immediately pull it inside the subsequent response. So as said here, you are effectively reducing table dumps to the single query if supported by the target. As said, though that functionality is being introduced into the database management systems for the last, I would say, 2-3 years. So if you have older target, you most probably won't be able to use it. But if you have a new target, you will, or I would say sql map will immediately try to use it. Only prerequisite is that union query SQL injection has to be usable by the target itself. Thing is that if you try to do the JSON aggregation inside the slower SQL injection techniques like the Boolean-based bind, where each bit of result is being pulled one bit at a time, you won't get any, I would say, speed ups. But if you have a fast SQL injection technique like the union query, where everything can be pulled inside the response page itself, the JSON aggregation is really a powerful tool to utilize. And how does it look like inside the one testing, I would say inside the testing environment? So here you can see the union query inside the location with that usage of that JSON aggregation function. And the thing is that this here is just the serialized JSON aggregation of that whole table being, I would say, injected into a single cell of the resulting table. And for example, if you have a single row per result, and if that single row per result can be used for the union SQL injection, SQL Map will try to use any of those cells inside the resulting table to inject the JSON aggregation of the whole table dumps once you run the SQL Map. How does it look like once being run, or I would say used by the SQL Map? So here you can see the MySQL version of that JSON aggregation function called Json Aggregation. So here inside the third column of the resulting cell, we are trying to aggregate the columns of the table test users, and everything is being done inside with the one query. So that's one HTTP request. You can see here inside the time span of 7 milliseconds. So you are really pulling everything you can in as least time as possible. And here you can see the deserialized version of that whole table num. So this is a serialized version, and this is being processed by the SQL Map to show you this kind of table dump.